We're going to use this video clips to quickly go through, this is very important questions that we ask ourselves. Why data structures? Why do we need data structure? What are the data structures? We will list out a couple of use cases and examples, and also some abstract data types that are associated with data structures as they relate to encapsulations and abstractions in object-oriented programming. The reason why we need them and the importance of using big O to estimate the performance of these data structures when they're put together and used by algorithms, computer science. Let's address the very top one. Data structure is a way of organizing, storing, and performing operations on data. So operation performed on a data structure includes accessing, updating, deleting, store data, right? We're searching for specific data, inserting new data, and removing data. There's a couple of important examples that I like to give. So basically, computers being as large as they are, capable of storing large amount of data, we as developers, programmers, we write instructions for a computer to, basically add on our behalf to efficiently manipulate these things, the data, hence the data structures. So data structures enable developers to conceptually process a large amount of data into a conceptually set of manageable relationship. Let me give you a couple of examples of basic data structure. You probably have heard some of those already. So one of them is array. If I had to draw this, so array is a data structure that stores an ordered list of items where each item is accessible by a positional index. There's also binary tree. Binary tree is a tree structure. Each node stores the data and has up to two children. So you have a node like this, and then you have two children, right, coming off of it. There's specific properties associated with the binary tree. Won't get into too much into it. There's also graph. This is another data structure. Graph is, a list of nodes connected either cyclically or acyclically to each other, map fashion. And there is no root descendant nodes and stuff like that, because a graph could just be a lateral metrics linked together. So you can also have linked lists, records, and I can go on and talk about different types of data structures. So basically, data structures are used for enabling fast data searching, enabling sorting of the data persistence, storing data, guaranteeing about algorithm complexity. So you can use different data structure to achieve different time and space efficiencies in computer science. What about abstract data types? There's one thing about data structure being concrete implementation of certain structures to store information. Abstract data type is more about the abstract layer that specifies a data type from its implementation. So you can think of the abstract data type being the difference between a Java interface and its concrete class implementations. Whereas data structure is like a concrete part of your data solution. Abstract data type is like a Java interface. It's basically a specification of a collection of objects and a set of operations that act on these objects. There are high-level abstractions. So let me give you some example. So we just talked about the data structure example. Some of the abstract data types that we're talking about, so one of them is what's called stack. So what is stack? Stack is a last in, first out abstract data type in which the items are only inserted or removed from the top of the stack. So there's last in, first out. The last item that goes in the stack is the first one to come out. So like if the last one is here, this is the first one that gets popped. Another one is called queue. Queue is another ADT, right? So queue is like a long line of people. It's first in, first out. It is an ADT in which items are inserted at the end of the queue and removed from the front of the queue. There's also priority queue. There's also set. And if you've taken Python before, there's what's called dictionary, which is a map. That is an ADT that associates or maps key with values. So that is, or dictionary. Okay, so these are ADT. If you look at encapsulation and abstraction, this is what you learn in OOP, Java, or C++, where they talk about encapsulation. Encapsulation is basically a data encapsulation and concealing the implementation of data type from the users. You can think of this data encapsulation in OOP as it applies to ADT. So this is the ADT part. And the other part is abstraction, like we just talked about that, the fact that you can provide these high-level functionalities and directing or declare, what the behavior of this thing is, say stack or queue, having first in, first out, last in, first out, right, type of behaviors on an ADT level. It is important to know that each data structure that we're covering in this class can be thought of a single unit, having a set of properties, behaviors, operations that we can perform, data access, data updates on these things. This is the reason why we're using data structure, because this allows us to efficiently process a large amount of data. That's it, period. When we're dealing with a large amount of data, of course, then we're dealing with time and space complexity, right? So time and space complexity is a concept that measures how efficient your data structure as relates to the algorithm that is using in terms of time, as in how fast, how efficient the solutions is, versus space, how much memory does it use. Together, they constitute different spectrums of efficiency measurements. In data structure class, we talked about big O notations, right? This video. So we'll talk about these, but hopefully this gives you a good introduction on data structure and why we're using them to begin with.